Okay, today we're going to be looking at the chapter on straight line graphs, and we're going to start with looking at gradients. So I've got 4 examples of how to find the gradient between a line joining 2 points, sketch them. There's a formula, either x1s and y1s and x2s and y2s, but if you just do some little sketching, so I'm going to plot 5, 2 for the first one there, and there's 5, and there's 2, and then I'm going to go 11 and 4, and I can then see quite clearly that I've got a change in x of 6, and a change in y of 2. I'm going to use m for gradient is 2 over 6, which is a third. For b, 2 minus 5 minus 6, 7, there's lots of minuses going on there, but if I draw them, so I'll go 2 along and 5 down, and then so minus 5 there, and 2 there, and then 6 back and 7 up, join them up like that. I'm going to draw my triangle, a little bit of a mess, but I've got minus 6 to 2, so I know I've gone along 8, and from 7 down to 5, I've gone down 12. And notice, because I've sketched it, I'm going downwards, so the gradient's minus. So I've got minus 12 over 8, and always cancel down. Try and leave them top heavy fractions. A couple of special cases here to be aware of. Minus 5, 4 to 15, 4. Well, all I'm going to do is plot them there and there. Minus 5 to 15. The 4, because y equals 4 is the equation. So y equals 4 is the equation, but the gradient is 0. Y doesn't change at all, so it's not sloping whatsoever. And 1 minus 3 to 127. There's my accurate sketch there. M is because it's a vertical line, we've got an infinite gradient. Okay, so apart from that, apart from horizontal, vertical, everything is linking y and x, and we've got sloping lines. That way for positive gradient, that way for negative gradient. Right, so let's have a look at how we apply it to some of the questions. We might be given a point and a gradient. There's a formula, which we'll look at later on, y minus y1 equals m bracket x minus x1, but there's nothing wrong with quoting y equals mx plus c, and then realising in this case y equals 2x plus c, because we're told the gradient's 2. And then sticking y is 9 when x is 4, 2 times 4 is 8 plus c, so c is 9 minus 8, which is 1, y equals 2x plus 1. There's my equation. For the second one, similar sort of thing, I'm going to go y equals minus 4x plus c, sticking y is 2 when x is minus 3, minus 4 times minus 3 is plus 12, plus c, so c is 2 minus 12, c is minus 10, and y equals minus 4x minus 10. We could write it, I don't like all those minuses, I could have written it as 4x plus y plus 10 equals 0. There's nothing wrong with that at all. Okay. Question 3 wants y-intercept, but it's not written as y equals, so I've got to make it y equals 2x minus 5, so the y-intercept is the point 0 minus 5. Once I've written it as y equals, I can read it off. I need to go 5y equals minus 15x plus 4, because it's not moved at all, and then divide by 5, and I'm going to get 4/5 from y-intercept. Well, just to finish off, minus 3x plus 4/5. So it's 0,4/5. Okay, so in each case, these versions are quite nice, as we'll see later on. We're doing things like solving simultaneous equations, and also stating where it crosses the x-axis, y-axis, which helps us sketch the thing. But this version helps me state what the gradient is, state what the intercept is. A few more examples, let's have a look. We're given the gradient and the y-intercept, but it wants the neatest equation because there isn't one answer. So I can say that this is an equation, y equals minus 3x plus 2/3. We've got fractions in. Let's times everything by 3. 3y equals minus 9x plus 2, or 9x plus 3y equals 2. That's the needed one because we've got no minuses in. It wants the equation that links 2 points. Well, as before, let's sketch them. Minus 2, 1, there, to the point 4, and then 5, there. So I'm going from 1 to 5, so I've gone up 4, and long from minus 2 to 4, 6. So m equals 4 over 6, which is 2/3. So y equals 2x over 3 plus c. And then stick either point in. So I can stick in, because I'll use that one. That one's got minuses in, don't like minuses. Y is 5 when x is 4. So I've got 2 times 4, 8 over 3 plus c. Top of your fractions, 5 is 15/3. So 15 minus 8c is 7/3. And then I can say that y is 2x over 3 plus 7/3, or 3y equals 2x plus 7. And I can check it, because when I put the other point in there, y is 1, that side is 3, x is minus 2, I've got minus 4 plus 7, which is 3. Both sides are equal. This equation satisfies both points. It's the only, whatever version I give me, this equation, or its equivalent, is the only one that goes between those 2 points. Last one, mentioned before, when I've got one of the numbers the same, simply x equals 7 is my equation. I don't even have to draw it. If the y number was the same, I could write y equals the value, but it wants the equation of the line, x equals 7 does the job.